Port 9 to Lone Wolf. We need that new kilopower generator plugged into the grid before the next dust storm hits us. Do you copy? Lone Wolf to base? That's a negative. The grid balancer software is stalled on a pending library update. We are at apoapsis, sir. Over. Lone Wolf, without the generator, the reduced solar energy during the storm would not be able to sustain critical life support systems. Over. Copy that. Trying a manual override to switch the generator with the solar module. Wish I could see my daughter. Over. Didn't you take a snap of her before you boarded the Dragon? Over. Yep, but I used the photo book app to take the snap, and now it wouldn't download either. Over.
Hey Hari, can you check the status on that video I just uploaded?
Upload suspended due to federal regulation violation, Article A51, Section 403.
What? Why?
Imagery or publications displaying, condoning, or associated with the consumption of bacon are prohibited as per Terran regulation.
Oh dear, I spent so much time perfecting that bacon recipe. Never mind. Hey Hari, can you play me some Honey Sing songs please?
Sorry, no Honey Sing songs are available on the Banana Music Store. All music with non-compliant Terran lyrical standards have been removed as per Article A51, Section 410.
Never mind. I'd much rather get some work done. Hey Hari, can you bring up the book Alice in Wonderland on my tablet?
Sorry, the book Alice in Wonderland has been removed from the internet due to the depiction of anthropomorphized animals as per Terran Regulation Article 51, Section 451.
Damn it! Okay Hari, search for books by Salman Rushdie. Wait, let me guess. No books found due to the violation of Terran Regulation Article 51, Section 404? Why the hell do I even pay internet bills when there's nothing available online anymore?
Would you like me to play the song All Hail Lord Doofus?
Hello world! The internet has empowered the growth of the human civilization to phenomenal heights through interconnectivity and freedom of expression. Yet HTTP, the protocol that lies at the heart of the internet revolution, has fundamental flaws, and if we are not careful in evolving our technologies, the consequences could be dystopian. In this episode, we will be exploring a new technology called the Interplanetary File System, and as ambitious as it sounds, Coupled with upcoming distributed web technologies such as the blockchain, it has tremendous potentials to save our freedom and empower humans to reach even greater heights. So without much further ado, let's dive straight. The Interplanetary File System, or IPFS, is defined as a peer-to-peer hypermedia protocol designed to make the web faster, secure, and more open. It is also defined as a distributed file system that seeks to connect all the computers within the network with the same system of files, quite similar to a single BitTorrent swarm exchanging Git objects. To understand this better, we will explore some of these concepts in the upcoming sections. Although hypothetical and highly dramatized, the opening clips in this video leads us to some clues as to why HTTP, the driver of today's web, can be considered to be broken. Initially developed and envisioned by Sir Tim Berners-Lee at CERN, the HTTP 1.1 protocol was formalized in RFC 2068 as a coordinated effort by the Internet Engineering Task Force and the World Wide Web Consortium in 1997. The original vision for this protocol was to empower a web of hypermedia information systems where hypertext documents included hyperlinks to other resources distributed across the web. Nearly 30 years later, however, with regards to HTTP, we observe the following trends on the web. The HTTP protocol addresses resources by their locations. In case the server at the specified address is taken down or is unreachable, the resource is no longer available to the entire network, and unless it was backed up by the Internet Archives, the resource could be lost forever. In a world swiftly migrating our memories to the cloud, this could lead to digital amnesia and a dystopian future, as depicted in novels such as Future Shock and Paycheck, where culture is ephemeral, history is lost and repeated, and the progress of civilization is hindered by myopic goals. Networked computer systems can be categorized as centralized, decentralized, or distributed based on the degree of interconnectivity between the nodes. In a centralized network topology, all client nodes connect to a central server node to fetch resources. Almost every major site on the web, including Facebook and YouTube, follow this model. In a decentralized network, there can be multiple interconnected or federating server nodes to which any client node can choose to connect to. Mastodon is a federated social network which follows this model. In distributed networks, there's no distinction between server or client nodes. All nodes can connect to each other as equals or peers. The torrent network is a distributed network. Centralized networks provide a single choke point which can be easily suspended by malicious hackers, governments, and even corporations and service providers by blocking access to a single location using firewalls, DNS poisoning, or DDoS attacks. Did you know a single viral video like that famous Gangnam Style song could cost up to $4 million to distribute? How? Let's do a bit of math. Now for tech giants such as YouTube, this figure might not be much, but for smaller companies, it might be an exorbitant price to bear for distribution. But what if we could distribute this cost across the network rather than one single server bearing the full cost of distribution? Hyper-centralized content leads to an over-dependency on the internet backbones to the data centers functioning. Censorship, submarine cables, and plans to colonize other planets raise a fundamental question. How do we operate our modern cloud-based systems if the backbone itself was unavailable? The scenario presented in Chapter 1 is still a real problem that exists today. A signal or data packet traveling at the fastest possible speed in the universe, the speed of light, could still take a very long time to travel between planets. Light travels at approximately 300,000 kilometers per second. Yet, owing to the vast interplanetary distances, it takes a beam of light between 3 and 22 minutes to travel from Earth to Mars, depending on the minimum and maximum distances between the two planets, at their periapsis and apoapsis phases respectively. So the HTTP protocol lacks a few key features required to elevate our civilization to a spacefaring Type 1 or Type 2 civilization on the Kardashev scale. But let us explore how IPFS could potentially solve some of these problems in the upcoming sections. When you add your files to IPFS, it is given a unique digital fingerprint using a cryptographic hash function like SHA-256 on the file's content. Similar to Git, IPFS uses a data structure called a directed acyclic graph, or specifically a Merkle DAG, to store objects internally. Each node in this graph is uniquely identified by the value of its cryptographic hash, also known as the content identifier or CID of that node. This also allows IPFS to prevent duplicates since the hash value of the same content is invariant. The fundamental abstraction used by IPFS for storage is an IPFS object. Each IPFS object has a CID, a data section capable of storing up to 256 kilobytes of data, and a link section which can point to other IPFS objects. Larger files which do not fit in a single IPFS object are split up into multiple blocks or IPFS objects, and a single IPFS object could then be used to link all of the pieces together. Similarly, you could model tree-like Unix directory structures using IPFS, where the top-level IPFS object representing the root folder could contain links to all the children files and folders, which could themselves have links to other files or pieces of a file. IPFS is an immutable data store, which means once a file has been added, you cannot change it anymore. But IPFS supports versioning using commit objects, which have parent and current object references. The parent object refers to a previous version of the object or is empty for the base commit version, and the current object refers to the IPFS object. When a new version is published for the same file, the IPFS software creates a new commit object, linking it back to the previous commit object, and this can be repeated endlessly, allowing you to maintain a file with its full revision history on the network. Contrary to HTTP, IPFS uses content-based resource addressing. Instead of a location, you ask the network for a content with the given cryptographic hash, and whichever node has the matching content would serve it to you. You could also verify that the content hasn't been tampered with using the same cryptographic hash. When multiple nodes in the network try to publish a file with the exact same content, the same cryptographic hash function would prevent duplicates from being created. A node could choose to pin any content to cater to future requests for the same content from other nodes in the network. This enables a certain degree of redundancy, which ensures permanence of data in case a single node hosting the IPFS object becomes unavailable to the network. However, despite this, a file could still become unavailable if all the nodes caching or pinning it becomes unavailable as well. The Filecoin project is an attempt to address this problem through incentivization and proactive distribution of resources in the network through a blockchain-based marketplace for file storage. To find the peers hosting the content you're after, IPFS uses a distributed hash table or DHT. A hash table is a database of keys to values, also known as a key value store, where the keys are hashes and all the data within the table is stored in one place. A distributed hash table is one where the key value store is split across all the peers in a distributed network. In IPFS, the values are blocks of data and the keys are the CIDs of those blocks. Each computer or node running IPFS holds a piece of the larger table. Nodes do not store information on what every other node is storing, since that wouldn't scale very well. But if the data is spread across many different nodes in the network, how does a single node in IPFS know where to find the data? To solve this problem, IPFS uses the libp2p project and a protocol called Kademlia to learn which node has what data. This is known as providing. Each IPFS node has a peer ID generated as a hash similar to the content IDs. IPFS nodes can provide a block of data when it either has the data or knows where to get it from. When trying to provide a block, your node will look for peers with peer IDs most similar to the CID of the block. How similar a peer ID is to a CID is defined as the exclusive OR distance between the bytes that make up the peer ID and the bytes that make up the CID. In this table, for example, we can see that QM Alex and QM Brian can provide QM VYD, QM Alex and QM Charlotte can provide QM ZIG, and only QM Charlotte can provide QM XPG. With all that theory out of the way, let's explore some of the software available for IPFS. There are three major tools available for IPFS: the IPFS desktop app, which offers a menu bar and tray shortcuts, and an easy visual interface for adding or pinning files, the IPFS browser companion, which adds IPFS URL support to the browser, and a CLI app. As developers, the simplest way to get started is the command line tool. You can install the CLI tool using Chocolatey on Windows or Homebrew on Mac. Unless you set up the IPFS path environment variable, IPFS would use a default path to store its internal files and configurations called the repository. Before using IPFS for the first time, you need to initialize the repository with the IPFS init command as shown here. Also, to be able to interact with other nodes, you will need to use the IPFS daemon command from another terminal to join your node with the public network. To add a new file to IPFS, you can use the IPFS add command, which outputs the CID on the terminal on success. You could then view this content from IPFS using the IPFS cat command and the CID from the previous command as input. Once added to IPFS, you could view your files from a browser or using the curl command as well. You can download IPFS objects to local storage using the IPFS pin add command. By default, the IPFS daemon also serves a web console on port 5001, which provides a view of the status such as network traffic and peer ID, files added or pinned, a Merkle DAG explorer, and a list of peers on the network. The IPFS browser companion extension for Chrome and Firefox not only adds support for the IPFS URL scheme, but also makes it easy to navigate the web console for status. The IPFS CLI provides many capabilities, such as finding all providers for a content using the IPFS DHT find profs command. The online CLI command guide is a highly recommended read for new users. There are many projects related to IPFS on GitHub worth exploring. The IPFS topics page, IPFS shipyard, and the awesome curated list for IPFS are some good starting points. In future exploratory projects, we might be looking at the PyIPFS HTTP client library as well. Well, this turned out to be a much longer video than I had expected, and we still skipped many topics such as IPNS, the shortcomings of IPFS, etc. But thank you so much for watching this video. Now, if you're wondering whatever happened to our ill-fated colony on Mars or the suppressed Terran Dominion citizens, please stick around just a little longer. If you liked this video, please don't forget to hit the like button. And if you'd like to view more such technical content in the future, please let me know in the comments below. And subscribe to my channel to support me. Signing off until the next time, over and out.
Main route to Mars Port 9, do you read me? Over. Mars Port 9 to Lone Wolf, we read you loud and clear. Do you have any status updates to share? Over. As a matter of fact, I do. I was able to fix the good balancer software. Looks like some of them base 5 have pinned with software patch files over IPFS during last query access. Over. Woohoo! That's music to our ears. Speaking of IPFS, Shweta had pinned some pictures of your daughter's last birthday party before she boarded the Dragon. We are sending over the CIDs to you. Over. Thank God. Being able to see one's daughter is a priceless feeling for a father. But I will buy you a drink once I return to base, Shweta. Lone Wolf, over and out.
Would you like me to upload your last recorded cover song to the Banana Music Store?
No thanks, Harry. I've already added the file to IPFS, and a lot of my friends have even pinned it. However, you could play the song for our viewers on YouTube.
Okay, playing recording now.
যদি কেড়ে নিতে বলে কবিতাটা শাখাটা যেন কেড়ে নিতে দেব না, যদি ছেড়ে যেতে বলে শহুরে কত কথা যেন আমি ছাড়তে দেব না। আর আমি জানি জানি চোরাবালি কতখানি ঘিরেছে আমাদের রোজ। আর আমি জানি জানি প্রতি রাতে হয় রানি হারানো শব্দের খোঁজ। আর এভাবেই নরম বালিশে তোমার ওই চোখের নালিশে বেঁচে থাক রাত পরীদের স্থান, ঠোঁটে নিয়ে বেঁচে থাকার গান। আর এভাবেই মুখের চাদরে পরিচিত হাতে জাগ্রত করি দের স্থান ঠোঁটে নিয়ে বাঁচে রাখার গান